Hello everyone. Today I'd like to discuss a cyber attack called ARP cache poisoning. So ARP stands for Address Resolution Protocol, and it's the glue between the link layer and the network layer. Because what it allows us to remember is a mapping from an IP address, IPv4 address, to a MAC address. So if I say I want to send traffic to a particular IP address, I look up in an ARP table and I say, oh, okay, that's actually where the link layer needs to route. That's the MAC address that my link layer needs to route the traffic to. Now, the problem with ARP is that it's a very trusting protocol. So anytime we get an ARP message saying this particular IP address is at this particular MAC address, we just automatically update our table that has this mapping, our so-called ARP cache. And this is really bad if a malicious actor comes in and starts sending rogue messages saying, well, guess what? That IP, that's actually my MAC address, or they can, they can mess it up however they want. So that's what I want to show you in this demo. But first, let me take a moment and set up a controlled software-defined network that I can experiment with this inside of. So I'm going to use something called Mininet, which is an awesome little tool. You can create these simulated networks on your own computer. And I have some boilerplate code here that I'm getting started with Mininet. I'll drop a link in the description to the Mininet website so you can read more. But anyway, okay, so in Mininet you can have hosts and switches. And a host can have an IP address and a MAC address, and it can be connected to switches. And the switches can be connected to each other too, so you can create a more complicated network. If you want a router in the mix, what you have to do is actually kind of upgrade the host to have routing capabilities. Now this is a program that only runs under Linux, so the way you can do that is, so it turns out each host ends up running on its own virtual, or its own process under Linux. And so you can actually just call Linux commands on the host. And it turns out Linux has a built-in routing capability for IPv4. And so basically when the host starts up, you just need to call this. Okay, so let me show you what I mean. So let me start by making the router. So I say, okay, my router is equal to, I'll say self.add-host. And I'll say, okay, I can specify an IP address. I'll say the IP, I'll make it 10.0.0.1. I'll make it 24-bit subnet. Which, yeah, that's I think 10.0.0.1 can actually, this is held aside for local area networks, so it could actually be an 8-bit subnet, but I'll make it 24 for now. I can also specify a MAC address, so maybe I'll make it something like 00000000 FACE. Okay, so I'll make my router the face of the operation. Okay, and the last thing I need to do is I need to specify, oops, let me get my head out of the way here. I need to specify that I'm using this special class to kind of upgrade the host to a router. Oh yeah, and I also need to make sure the first parameter is the name that Mininet's going to use to refer to this in its little terminal. So I'll call this R1. Okay, so now let me make a switch that I'm going to plug this router into. So I'll say self.add switch. I'll call it S1, and that's actually all I need for this. The switch is pretty simple, just plug things into it. Now let me make some more hosts. Okay, so I'm going to make two hosts, and they're not going to be routers, they're just going to be ordinary hosts. I'll call the first one H1 for host 1. I'll give it an IP address of .10 on the subnet here, and I'll give it a MAC address of 0001. I also have to say that if I get traffic and I don't know where to go, this has a default route. So you could do this in the command line. I could actually call the command line in H1 and do this, but Mininet has a parameter to do this. I'll just say default route equals via 10.0.0.1. So this is telling it, okay, look, when you go to route traffic, if you don't know where to go, send it to the router at this IP address. Okay, so that's all we need there. And then let me make just another host. So I'll call this one H2. I'll give it an IP address .20 there with the MAC address of 02. And finally, let me connect these all to the switch. So I'll say self.add link between the router and the switch. I will also add a link between the host and the switch, host 1, and then I'll add a link between the second host and the switch. Okay, so now I'm actually going to open up Wireshark because I want to show you something about the network I just created. So I pop this up, and right now I just see some ordinary devices like my Bluetooth and my wireless. But if I go and then run this code that I just created, so if I say sudo python3 network.py, this opens up a little command line interface here for this network I just made, and I can see that that's exactly what I configured here. I also see 3 new devices popped up in Wireshark. And each of these devices is a network interface controller on the switch that I created. So S1 ETH1 is the first thing I plugged, network interface controller for the first port on the switch. So that would be the one that's connected to the router. The second one would be the one that's connected to host 1. So they get added in the order that I added them here. So then the third one, S1 E3 would be the one connected to the second host there. Okay. Okay, so let me go ahead and listen at the router for a moment. And what I'm going to do is go back to the Mininet command line interface and ping the second host. So I know that's at 10.0.0.20. Ping the second host from the first host. Now when I do this, I immediately see one packet that pops up at the router. And this is an ARP broadcast. And so what this does is says, so now we're finally going to see the ARP protocol in action. This says, hey, I'm coming from MAC address 01. If you remember, that's the one I set up for the first host, H1, that I just sent the ping from. I'm at host 01 here. And I don't really know who I'm looking for. I don't know where they are. But I know that they have the IP address .20 in my subnet. I don't know what the MAC address is, but here's where I'm coming from. I'm .10 and I'm coming from MAC address 01. Tell me, where is MAC address .20? Now this gets broadcast to everybody on the switch because it's going to the broadcast address here, the all ones Ethernet address, MAC address. So the router gets it, but the router is not actually 10.0.0.20, so the router doesn't send a reply. Okay, so let me restart Mininet, and I'm going to do this again, but this time I'm going to listen at the switch port that's connected to H1, which would be S1 ETH2, as I discussed before. So let me start listening here, and now if I do this, let me just stop this for a second. If I do this H1 ping again, what I will see is something very different. So I still get that broadcast ARP request, but now I get an ARP reply. I'm able to hear that, oh, actually, the H2 device says, oh, you're asking for me. Let me reply and tell you who I am. So let me look in detail at the ARP messages here. So the request again says, hey, I don't know what MAC address you are, but I'm looking for 10.0.0.20. Host 2 gets that and says, hey, I'm 10.0.0.20. So what I'm going to do is send you a reply and tell you that. So this is my MAC address, 02, and it corresponds to that IP address you're asking for. Let me send it back to you. You were the person who asked for this. And once that's been established, host 2 actually in the process has found out exactly who host 1 is. So host 2's ARP table can store the MAC address for host 1, the .10 address. And then once host 1 gets the reply, it can store host 2's MAC address. And so now they can communicate with these ICMP messages, the request and the reply. So now the ping actually works. Okay, so if I just pick apart just for a moment the ARP packet here, the ARP payload, because this is something I'm going to have to do if I want to spoof these. So let me understand the format here. In the Ethernet header, it's pretty standard like it always is. The ARP reply actually knows exactly where we're sending it to, so we're not going to do a broadcast anymore. but the ARP request has the broadcast. And then the type, instead of being IPv4, which is 0800, it's going to be type ARP. That actually has to go in the link layer header there. So 0806 is for ARP. Now the ARP payload itself, the first 2 bytes are 0001, that specifies Ethernet. Then we have 0800, which is, as I said, the magic number for IPv4. Hardware size 6, that says MAC addresses are 6 bytes. Protocol size 4, that says that the IP addresses are 4 bytes. When it's a request, the next 2 bytes, the opcode is 1. When it's a reply, the opcode is 2. So that's the only difference between those there. And then finally, we have the real meat of the packet, the information. So we've got 6 bytes for the sender MAC address, 4 bytes for the sender IP address, 6 bytes for the target MAC address, 4 bytes for the target IP. Okay, so that's the ARP header in a nutshell. So everything seems to be working great. And under normal circumstances, here's the kind of communication we would see. So we have here the router. So I'll say 10.0.0.1, so this is the router. And then I have host 1 and host 2. So I'll say H1 here, this is 10.0.0.10, and then host 2 is 10.0.0.20. And actually, this is just communication that's happening between H1 and H2. But let me think about a slightly different scenario here where H1 is communicating with the router. So I'll change it up a little bit, and then I'll show you what the attack is here. So let's say that H1 wanted to ping the router. So when it would do that, it would send out an ARP request, and then the router would tell who it is. And then they would be able to do two-way communication. So here is the arrow. So let's think about, okay, the MAC address of the router was this, and then the MAC address at the host 1 was that 01, right? Okay. So yeah, under ordinary circumstances, when the host 1 wants to communicate with the router, once the ARP stuff has happened, it will know that it's supposed to address a packet to the address 10.0.0.1 at this MAC address here. So that's all great. And then when the router wants to communicate with H1, it knows that it has to send traffic to 10.0.0.10, and it's going to have remembered from the ARP transaction the MAC address 01 for that. All right. So when we go the other way, we're targeting the IP address like that, and MAC address 01. Okay. But now let's say H2 was malicious and wanted to get in the middle. So H2 has a different IP address and a different MAC address. So this has the MAC address 02 there. Oh, looks like I forgot a 0 pair here. Okay, let's see. 1 byte, 2 byte, 3 byte, 4 byte, 5 byte, 6 byte. Okay, there, now we're good. Anyway, okay, so this is H2. H2 wants to get in the middle. And so what H2 has to do is really two things, actually, if it really wants to be in the middle. It has to convince the router that it is H1, and it has to convince H1 that it is the router. So when the router goes to address H1, we need to convince the router to use H2's MAC address. All right? So it's like, hey, I'm trying to communicate with 10.0.0.10, but I've been Jedi mind tricked into using the MAC address 02. Okay? And when the host wants to communicate with the router, it says, okay, yeah, I'm trying to send a packet to 10.0.0.1, but I've been mind tricked into thinking that is also at IP address, or at the MAC address 02 there. So this is the traffic that I have to orchestrate. And if I want, I can just do a full-on denial of service, just like drop these packets and don't even send them on. But if I wanted to, if I got a packet from H1 that was on its way to the router, I could just continue this through here and send it on to the router if I wanted. And then I could also continue this through the other way. I'm not going to worry about that here. I'm actually just going to do denial of service just to show the concept. So yeah, let me try to do this. So what I have to do is send out ARP reply. So it turns out anytime I get an ARP reply with this kind of information, the hosts are going to update their ARP tables. And same for the router. So I can just send out these ARP replies with whatever information I want. So what I'll be wanting to do here is send out an ARP reply from H2 to the router, announcing that the IP address 10.0.0.10 is actually at H2's MAC address. And then I'm going to want to send out an ARP reply from H2 to H1, announcing that the router's IP address is at H2's MAC address. Okay, so what I want to do actually is pull out H2. H2 is going to be a little malicious host. Let me pull that out into its own terminal. I can do that actually. If I type dump here in Mininet, I see that H2 has the process ID 42617. So in another terminal, I can say sudo mn exec a give the process ID, and I'm going to say bash. Okay, so if I do that and I get my password right, then now I have a terminal that's on H2. Okay. So if I say if config here, I will see, okay, indeed, that's my IP address. The network interface controller on H2 that uses communicate with the switch is actually called H2 ETH0. Okay. So on the other side, when it's connected to the switch, it happens to be called S1 ETH3, as we saw. But the network interface controller connected to the host H2 is called H2 ETH0. So I can do things like ping the router 10.0.0.1. I can also ping the other host 10.0.0.10. So this all seems to be working. That's great. But I want to run a malicious script on this host. So let me do that. And I've input some of the information already that is going to help me here. So I've inputted the MAC address and the IP address of everything that I've set up on this network. Now what I need to do is set up a raw socket that's going to run at the link layer. And this socket is going to send out these malicious ARP packets, which I'll construct in a moment. But so to construct a link layer socket, what I have to say is socket.af packet. That's down at the link layer there. And I'll say socket.sock raw. Okay, so this is going to allow me to send raw link layer traffic. And then I'm going to bind that. So I'm going to say sock.bind. And as we just saw, this is, actually let me check again, I already forgot. If config. Okay, the device here is H2 ETH0, right, okay. H2 ETH0. And actually this doesn't matter, there's no real notion of a port here, but I do need to specify that argument. Okay, so this is going to bind the socket. If I were to run this program here, it's actually not going to do a whole lot, but just make sure I can run it. Okay, it ran and finished. It didn't give me any errors trying to set up that socket. Because actually I'm in administrator mode. I have to be in administrator mode in order to run a raw socket at the link layer. Okay, so let me try to define a method that's general enough to do the kind of trickery that I want to do here. So I'll say def spoof, and it needs to know the attacker's MAC address. It also needs to know the target IP address that we're trying to trick somebody into sending to us. And then we also need to know the victim's MAC address, and we need to know the victim's IP address. So let's go ahead and make this packet. So first I need to make the link layer packet. And I'm going to say, okay, this ARP reply, so let me go back here, I've got an ARP reply. We're going to send this ARP reply from our MAC address. So that's going to be the source MAC address. We're going to be sending it to the victim's MAC address. So I'll say victim MAC. So it's always the destination MAC address first in the link layer header. And the source is going to be coming from us, the attacker. All right, and then as I was telling you, the 2 bytes that come after that are 0806. Because that is what indicates that this is an ARP message here. So yeah, if I look, there we go, 0806. All right. Now after that, we've got, let me actually import the struct class to help me out here. And let me put this side by side so I can have a look as I'm doing this. So, okay, so the next 2 bytes are going to be Ethernet. So yeah, let me now make the ARP packet. So I'm going to say struct.pack. Okay, so we got, first we've got 1, which is Ethernet. Then we've got, actually, yeah, so then I'll just say ARP plus equals bytes 0, 0, 8, 0, 0, 0, which that is the IP, IPv4 coming next. Then I'll say ARP plus equals struct.pack. I've got 2 half words here. One is going to be 6, the other one's going to be 4. And actually this is a reply. Okay, so I'll do HHH, so I got 6, 4, 2. So 6 bytes for MAC, 4 bytes for IPv4, and then 2 is the opcode that I'm using for a reply. Now I have the sender MAC address, who I'm happy to spoof and report as the attacker's MAC address. Okay, so here's sender MAC. Sender IP, on the other hand, we want to make them believe that this was the target IP that they would eventually want to hit up, which is not us, but we're going to make them hit us instead. So this is the IP we're spoofing with our MAC address. And now we just say, hey, you know what? Who am I telling this to? I'm telling this to the victim. So I'll say ARP plus equals victim MAC, and then finally the victim IP address. All right. So let's see if I got this right. Oh yeah, and of course I have to send this out. So maybe I'll pass the socket along as the first argument, and then I'll say sock.send. Yeah, it should just be send. I'll append the ARP bytes to the link path bytes there. Okay, so let me go down here, and first what I'll do is I will make, okay, so I'm going to use H2's MAC address, right? And let me make the router think that, or let's see, okay, maybe I'll start by making H1 think that the router's IP address is me, H2. So let me make H1 think that the router is actually at H2's address. So I'm going to pass along H1's MAC and H1's IP. Okay, so to test this out, what I'm going to do is pop back into, okay, let me stop that pinging that was happening here. Okay, so yeah, I just need to run the script in the right place. So I'm going to actually listen at the port that H2 is connected to, the one that I'm doing the attack from, and let me run this script from H2. Okay, so I saw this ARP packet went out. Let me just make sure it's formatted properly first. And I can see I actually made a mistake. This is not aligned properly, because these are definitely not the IP addresses, and I have some junk at the end here that didn't mean to be there. Because what I did was I accidentally used 2 bytes for the hardware size and the protocol size. Those are only 1 byte. So let me go back and fix that. The hardware size and the protocol size are only supposed to be 1 byte long. So let me try this again. Open up the terminal here. Send out the ARP packet, and now this looks like it has what I want. So let's check. I'm trying to convince .10 here that I'm the router. I'm at MAC address 02, but I'm pretending that is the IP address .1 there. Okay, great. So let me now go and listen at, oh no, actually I can keep listening here. Okay, this is fine. I'm going to keep listening here. Let me run this again. And now let me go back to the Mininet and try to ping the router from first host. And now what I see, oh, this actually worked. Okay, maybe the ARP cache went stale. Let me just see here if I run this again. Okay, so now I'm getting blocked. Okay, so if I look at this, I'm not getting any ping replies. But on host 2, I'm intercepting all the traffic that's going out. So it's trying to ping the router, but it's sending its packets to me. And I'm doing a denial of service because I'm not passing those packets along. Now, if I wait long enough, eventually the ARP cache on H1 will go stale and it'll send out a new ARP request. And I'll wait for a second for that to happen. Okay, it just happened. And so if I go and I look up at the traffic here, and let me kill this now. So I got it to drop a lot of packets because I put myself as the man in the middle at H2. So when H1 tried to ping the router, it dropped all these packets. But eventually, the ARP cache at 10, my victim went stale, and it sent out another ARP message. And at that time, the correct host replied with its MAC address, and then the pinging was able to work again. Okay, so that's the ARP attack. And of course, you know, I could, if I wanted to, I could convince the router that .1 is me. So I could call this spoof method again, saying that, okay, I want to convince the router that H1's IP address is me. So now the router becomes the victim, and I can do this both ways. All right. And as I was saying, if you want you know to be a true man in the middle, you can do more than just a denial of service. You can actually say, okay, I intercepted a packet on the way from H1 to the router. I can send that packet directly over to the router, so that the router doesn't suspect anything. And I can do the same thing the other way. Or I could actually modify the traffic if I wanted to. I could put a malware or something. So this is like a little bit scary, how easy this is. I'm doing it on a simulated network here because I don't want to mess up my own network. But yeah, this is a reminder to be very careful when you're on a public network. Definitely use encrypted traffic. And if you're on your home network, do a good job to secure it. And if you're using Wi-Fi, use a strong password so that nobody can get onto your switch and do this sort of thing. But I should mention actually that ARP has been superseded in IPv6 by something called NDP, the Neighbor Discovery Protocol, which actually adds encryption to this. So you have to prove that you're the one who's allowed to say that this is your MAC address. So hopefully someday we'll all transition to IPv6. But for now, this is something we really have to still worry about because as far as I know, I think only about a third of internet traffic uses IPv6 right now. Okay, but we'll get there someday. But just be safe in the meantime, all right? Take it easy.